Greetings. Thank you for joining myself, and I'm going to introduce some other folks shortly who are going to be part of this Faster for AI with Unified Data session. My name is Alaric Thomas. I lead product management for a product called the Ezmeral Data Fabric, and that's what we're going to be talking about and how that leads to faster AI with unified data. Before I get into the detail of the presentation and the major pieces of content in the presentation, I've got a couple of slides, sort of admin slides I'm going to need to talk through. Firstly, this one, I'm a product manager. I'm going to try and show you a bit of the product, and I'll also talk about what we have in the product today and also where we're going in the future. So I need to show this disclaimer just to say some of the things I'm going to discuss are going to be roadmap related. And then you've probably seen this in the next slide I'm going to show on PCAI. These are to reinforce the announcements that were made in the Spotlight session, announcements made by Antonio, and then Fidelma has also followed this up and talked in more detail about it. Basically, the collaboration between NVIDIA and HPE around not just NVIDIA's GPUs and putting GPUs into HPE hardware. I mean, that's been possible for many years. You've been able to buy a range of HPE servers with GPUs in them. But it's also around the economics and the economics that we can provide and the options we can provide through acquiring those things through GreenLake. The technology is not just about that hardware layer, it's about the software layers above it as well. And so giving you not just the GPUs and the hardware, but actually giving you an end-to-end solution, which is rack to end-user-facing AI tools. And then the third part is the people. So the skills at HPE and our ability to come and help and provide guidance and provide assistance to help you along on your AI journeys. And then the second slide, which is actually much more germane to the data fabric as well, actually, is the private cloud for AI. So the private cloud for AI, which has been announced and discussed, it's really an appliance. So it's hardware, software, services, with the goal of supporting modern AI workloads. One of the main components inside of private cloud for AI is the Ezmeral Data Fabric. The Ezmeral Data Fabric provides a hybrid data lake inside of private cloud for AI, so that as your data scientists are interacting with the tools in it, they can connect to data that's either in the fabric or they can connect to data that's federated in external sources as well. So I'm going to talk more about that as we go through the presentation. So I have quite a few things to talk through. I'm going to start off by looking at what does the new type of AI that's happening, basically the large language model type AI and the use cases and the workloads there, what does that mean as far as the amount of data that's being stored and the expectation, what that looks like, so, and how that drives complexity for managing your data landscape. The hybrid data landscape, actually nothing new, but it's another set of challenges around managing data for the multiple types of workloads that we see in the enterprise today. And then I'll talk about the data fabric as a foundation to provide solutions to these challenges. And if I've got time, I'll give you a very quick demo as well, show you a couple of concepts in the product. So I always like to say the proof of the pudding is in the eating, so I'd like to show you that. And then very privileged to have two gentlemen with me, Debaji and Nilamba. Debaji is from Amdocs. Nilamba is from SBI Bank. They're big users of the data fabric, been using it for many years. They're going to join me up here for a little Q&A, a little panel discussion. They'll share their experiences with the data fabric and talk about what their direction looks like as well. So you're not just hearing it from the product manager. So the unstructured data explosion. Actually, when I put this graph together, I found it actually quite surprising. The y-axis is a linear axis. So what I did is I basically said, what were the general eras of computing? And then what does the amount of data that was being managed in those eras look like? So if you go back to the very early computing days, with punch cards and computers that would fit in rooms, you were talking about probably K of data that you can store in these things with those little copper cores, and then maybe a megabyte of data that you load through punch cards. The next era, the personal computer era, you know, we had hard drives, we had those 5.25-inch floppy disks in those days, the big ones. So maybe we're looking at a gigabyte of data. The internet and the multimedia revolution, the internet and the multimedia revolution. What was happening there as well was a lot of data was now getting captured and stored in very highly structured databases, relational databases, operational stores. And then from there led the notion that we need to make some decisions on top of this stuff. So we were putting it in Snowflake schemas and star schemas, things like that. And by then we're in the terabytes, so a terabyte of data. Next era was the big data era. So come the big data era, everybody's looking at these, you know, Google and how they're storing their data, and they wrote a white paper, and that started a whole industry of big data. And this was really the inception of the data fabric back in the big data days. And then we were looking at, you know, I was working on the data fabric back in those days, and we would look at, you know, a couple of petabytes as actually a big store. But customers were bringing the data, they were putting the data and slowly growing their stores. And then, as you see, the amounts of data that was being consumed and stored there doesn't even register on this graph. It's only when you get to AI, and then especially the neural net type of AI, which is being adopted today, is actually driving a massive explosion in the amount of data that's being stored. So as I look at some of the use cases that our customers have, you can, if you go down, you see the BMW car on the show floor. They actually collect data, store it in a fabric, and they use it for training their autonomous driving systems. They're very comfortably in the hundreds of petabytes. And so the need to store that amount of data, very, very real. We've got a handful of customers like that. And I'm sure we'll see an exabyte soon, and I'm sure we'll see multiple exabytes following that. And so what does that mean? Managing that amount of data, there's a lot of complexity in managing that amount of data at that sort of scale. Firstly, do you know what you have? You probably don't have it all in one place. Providing a security layer over there, managing duplication, managing compliance, managing lineage, large number of factors, large number of things that you need to take into account to actually manage this ever-growing amount of data, this requirement to store an ever-large growing amount of data. And then the second view, not a particularly new picture, but the second view is still very germane. You know, the world has become hybrid. You see that in the center orange, that center orange bar represents 20% of an enterprise's data today. Quite typical, that's where the data fabric would live. That's where the data fabric's data lakes would get built, and they would be feeds of data coming into them. But as the world became hybrid, as the clouds emerged or the clouds formed, you know, customers started moving data out to the cloud, and they had hybrid use cases, and then invariably quite a few of them brought it back on-prem when they realized how expensive the cloud was. But the clouds are, you know, certainly fill a significant number of use cases very efficiently. So the cloud is here to stay. And then the edge, as the slide says, 50% of the data is generated at the edge. These are IDC numbers, by the way. 50% of the data is generated at the edge. The strategy there is usually to pick up the exceptions and alert on the exceptions, and then to only keep what is germane, only keep what is interesting, and move that back into a data center for further analysis and for historical analysis, or even prediction with AI models as well. So again, this hybrid environment adds challenges for management, adds challenges for control, adds challenges for visibility. So for the data fabric, so what we've been doing with the data fabric is, as I said, the data fabric started as a data lakehouse. So single deployment of the fabric. We started with files and use cases around files. So it had HDFS APIs and a couple of other APIs. Very quickly, we added the capability to store semi-structured data in it. So you can actually store columnar stores in there. We have customers storing data stretching to the billions of rows in our columnar stores. Event streams, so the fabric can act as a topic, basically, so you can stream Kafka-compliant data into the data fabric and that's becoming actually quite, a couple of governments are actually using that at scale at the moment. Telcos as well are using that at scale at the moment. And we added an object interface on top of the Fabric as well in the not too distant past. And so the Fabric provides this support for multiple types of data, so storage of multiple types of data. In addition to that, as part of the hybrid world, we recognize that data is not just stored in the Fabric in an enterprise. It could be stored in a variety of stores. Weka, VAST, Scality, we've certified them all and tested them all so we can federate them within the Fabric. Another thing on top of the types and the federation that we've done is we've had this concept in the Fabric called a global namespace for quite some time. In fact, from day one, we had a global namespace. And what we've been doing is we've been expanding our global namespace. So our global namespace provides visibility into the data that's not just in the Fabric, but the data that's also federated under the Fabric. So now you have a single control plane that allows you to see what you've got. Secondly, you can start applying security. Roles, security RBAC support. And security RBAC support at the global namespace level. And I'll give you a quick preview of what the global namespace looks like actually inside the product. We're adding other things like some more modern interfaces, like the Iceberg interface. So if you want to have Iceberg clients, you can connect them directly to the Fabric. We've got some cool things we're going to be doing, cool things on the roadmap to improve our Iceberg support as well. And then, of course, the Fabric, you can deploy it in a number of places. And we're actually making quite a few improvements, and we're moving forwards with how easy it is to deploy the Fabric in a number of different locations. And I'll be able to demo some of that as well for you. And then my last slide, which I'll go through pretty quickly because I want to actually get to the panel discussion. So I'm not going to go through every one of the boxes on the slide. Just a couple of things I'll pick on. So the external data sources that I mentioned, the ones that I've listed on the slide are the ones we currently certify, but pretty much any external S3 source, any NFS4 source, we can federate inside the global namespace. Things specific on the AI topic, the NVIDIA GPU Direct support, so we have that support. We're updating it in the current release. Streams, we're actually updating that API in the current release as well, and we keep all of those things current. And then there's all of the management capabilities that are in the Fabric that allow you to do things like monitor the Fabric and make sure that the Fabric is secure. And then the last thing I'll mention before I actually swap across and show you the demo is the ability to provide audit and governance data and security data based on what data you have in the Fabric, and as we look forwards, it'll expand more and more to the data we federate as well. So where that comes from is we've always had really good auditing capabilities in our Fabric. So we can tell you who created something, who edited it, who deleted it, who updated it. And so what we've been doing is we now collect that data. If you turn it on for a particular volume or bucket, we now collect that data, we put it in our own bucket, and then we make sure it's Iceberg compliant. So now any Iceberg compliant tool you can get to build your own governance or lineage or security monitoring application. I'm going to swap across and show you a demo. Good, the screen came back. So I mentioned the global namespace. So this is our graphical visualization, my graphical visualization of what we call our global namespace. So what we have here is, I'm logged in as what we call a Fabric user. A Fabric user is somebody who consumes resources. So maybe it's a data scientist or a data engineer. They want access to volumes, buckets, data, so that they can build their own applications. And this particular user, they can see this tree of resources. And what I actually have here is I have two separate data fabrics. So I have a data fabric here, and I have a data fabric here. These are running in a development center, but they would be the equivalent to ones running on-prem. They can be in separate geographic locations. Doesn't really matter as long as the network connectivity is good between them. You can have as many of them as you want, and yeah, you can put them wherever you want. So as say, data engineer or data scientist, if I want access to any of the data that's in there, I can click here and I can say View Access Points. Now that root node, that root mount point will actually, if I mount that, that will give me access to any of the volumes that I've been given access to in this entire global namespace. And in fact, it's not just for the items that are in my tree in the data fabric, but also for external ones as well, external NFS ones as well. And I have the same thing for S3 servers as well. So if I generate this key will give me access to any of the buckets as long as I have permissions on those buckets that are in this global namespace. So firstly, as an application developer, my life has really been simplified there. I don't have to go searching for individual buckets and data out of individual, or not the data out of individual buckets. I don't have to go searching for individual buckets and how to get access to it and finding the right keys. The fabric is going to generate the keys for me and take care of the access seamlessly underneath. So those are the two fabrics here at this level. I'm going to come back and talk about those 4 source types in a minute. We also have an external NFS represented in this global namespace. So that could be an NFS in the cloud. That one's actually a Ganesha running again in one of our internal labs. It can be any external NFS store. It could be VAST file. It could be GreenLake file. It could be VAST. Doesn't matter. And then the third one is actually a Scality box that we have network connectivity to. That Scality box, that's an S3 store. You can see there are buckets under it. And just briefly on the multi-type support, as you can see here, this fabric's got several buckets created. There are buckets here. It's got several tables created. It's got several volumes created and several topics created as well. And as long as I have permissions, it's actually very easy for me to go create these things myself. Let's actually just choose to create a bucket. Now, I give it a name, and you notice I can actually choose, do I want to create it in one of my data fabrics, or do I want to create it in an external S3 store? So if I've got connectivity to S3, I could go create a bucket in S3 if I wanted to. Scality, VAST, those sorts of things, I can connect it to an external one. I'm actually not going to go and create a bucket, but you'd give it an account name. You can enable object locking and versioning as a pretty standard things for the S3 protocol. Just say create, and off it goes, and it will create the bucket for you and add it to the list of buckets. So for example, it would add it to, there's just one bucket there. So that's a quick preview of the global namespace. Let me just show you, it's very similar for bucket, it's very similar for topic, it's very similar for table. For those of you who know the data fabric, you'll know a different interface, our MCS interface. Our MCS interface is very verbose. It tells you a lot and gives you a lot of control, but you need quite a bit of knowledge to use it. The goal of this interface is providing users who do not know about the details of the fabric access to it and the ability to use it and take advantage of the data that's in it. Let me go show one last thing. So I mentioned I'm a Fabric user. I'm going to go to a Fabric Manager persona. The Fabric Manager doesn't actually get access to the data, but they get access to the resources. So as you can see, as a Fabric Manager, I can create an external, I can import external S3 sources. So as I mentioned, I can go to AWS, I can go to generic S3 source. I need to swap the keys, and that would create an external S3 source here. I can actually import fabrics I already have. You have to make sure that the auth models are syncable. So we've standardized on using Keycloak for auth, and we will point to your external identity and access management system through Keycloak. And as long as you've synchronized that with the external fabric, you can import an external fabric into this global namespace. It will look just like the other ones that I've showed you. Creating fabrics. So I mentioned the world is hybrid, and everybody's got data everywhere. So one of the things that often comes up is, can you put fabrics in the cloud? So you can deploy fabrics, of course, in the 3 clouds through here, and there's the on-prem option at the bottom as well. Another thing we're doing with fabrics in the cloud is we will be supporting in the next release the ability to support fabrics that do not do any replication. So the Fabric, one of the default capabilities of the Fabric is it replicates your data. So if you lose disks or you lose servers or you lose racks, as long as you've got enough nodes and racks, you won't lose data. However, when you put that in the cloud, you actually end up multiplying out the replication that the cloud gives you. And so one of the things we're doing in a coming release, and it'll be available very shortly, is the ability to run with what we call one-way replication. So we're not doing the replication, the cloud is doing the replication for you. You can still deploy multiple nodes in the cloud, and so what you end up with is service resilience and then the data resilience provided by the cloud. And so your costs will be, it helps you manage costs as well. It depends on the use case. You can, of course, deploy with multiple levels of replication if you wish, but yeah. For the cloud, you probably do not want to do that. Then, of course, you can deploy on-prem as well. I'm not going to go through the dialogue to go setting up what this looks like on-prem. We basically ask for a set of IP addresses. We're going to go do a lot of checks on those machines, make sure that the OS is installed and it's a supported OS, and make sure the Java version is correct, and then we lay out the Fabric on it for you, and it'll appear in this tree diagram. That concludes all the content we have, and we've got a couple of minutes left. There are multiple things happening. I'm sure you've seen it's a great conference, very well attended, lots of very good things here. I'd recommend dropping by if you've not been and seen that i7 BMW. That's a pretty cool piece of technology. There's some data fabric in the background there. So actually a couple of systems are driven by the data fabric. One of them very germane to what some of the technology in that car. So I recommend stopping by, having a look at that. There's a guy, Dirk, there. Just say, Dirk, I hear you've got the keys to the car. Can I have a look at it? There's some good demos running. And then, yeah, we have Twitter feeds and things like that, or the X feeds and things like that. So with that, I'm going to wrap up the session. If anybody has any questions, I'll stay up here. I'll be around. And yeah, hopefully this has been very, very insightful for everybody. Thank you very much. Thanks.